We have started with a projectile in our first video and second video. This is another video, which is third video on projectile. We have given the definition of projectile, examples of projectile used in sports, used in warfare, definition of a trajectory of a projectile. Then we divided projectile into two: one-dimensional projectile, two-dimensional projectile. A one-dimensional projectile is divided into two: vertical motion and the horizontal motion. Vertical motion is divided into upward motion and downward motion. Then we look at horizontal motion. We have done vertical motion, upward and downward. We have started horizontal motion. So we continue from where we stopped. So the next thing is example. Example 1 under horizontal motion. Example 1. A particle is projected horizontally from the top of a building, 80 meter high. From the top of a building 80 meter high. Calculate the horizontal distance, that's the range. Horizontal distance covered when the particle is projected at 30 meters per second. In the first video, we derived under horizontal motion, T is equal to square root of 2h over g. We have done this. We derive range to be equal to ut under horizontal motion. Now, in this question, we are giving u to be equal to 30 meters per second, comma. We are given height to be equal to 80 meters. So we have to find the range. How do we determine the range? Definitely 30 is given as u, but t is unknown. So we use this formula to get our t. So if we use this formula, it will be square root of 2 times 80 divided by 10. 2 times 80 divided by 10. Cancelled. You have square root of 16. This one will give you 4 seconds. Don't forget to put the units. 4 seconds. So we have gotten the time to be 4 seconds. So therefore, our range will now be, we say ut. U is given to be 30 times t. That is 4. So the answer is 120 meters. That is example 1 under horizontal motion. Example 2. The horizontal distance covered by a body projected horizontally at 50 meters per second, projected horizontally at 50 meters per second from the top of a cliff is 140 meters per second. 140 meters. That's the horizontal rate. Calculate the height of the cliff. Calculate the height of the cliff. These are the ways of asking questions, especially in calculation involving horizontal motion. Then from the question, we are giving u to be equals to 50 meter per second. We are giving the horizontal distance to be equals to 140 meter. Then we have to find the height. We all know height is equals to half gt squared. This has been derived in our second video. H is equals to half gt squared. So our problem now is t. We don't know how to get t. We know 10. 10 is constant. G is constant to be 10 meter per second squared. So our problem now is t. How do we get t? Then I will say recall that r is equals to ut. R is given to be 140 is equals to u. U is 50, then times t. T now is equals to 140 divided by 50. Cancelled, cancelled. T now is equals to, we have 2.8. That is seconds. That's the time. So we have gotten the time to be 2 seconds. So to calculate the height, we say height is equals to half gt squared. H is equals to half times 10 times g. What is times t? 2.8 squared. H now is equals to 5 times 2.8 squared. So H now is equals to whatever you get is in meters. It's in meters. This is how to calculate the height if the horizontal distance is given to be 140 meter. This will mark the end of horizontal motion. Two-dimensional projectile. Two-dimensional projectile. Two-dimensional projectile. Projectile in two dimension. Under projectile in 2 dimension, we have this. The initial velocity is inclined at an angle theta to the horizontal. It's inclined at an angle theta to the horizontal. This is the time taken to reach the maximum height, and this is the time taken to return to the plane of projection. From here to here, we call it maximum height. That's the maximum height attained. But at this point, it has not attained the maximum height. We call it a vertical distance covered, while the corresponding horizontal distance covered. Horizontal distance covered. That's the distance. But the total distance, horizontal distance covered here, is what we call the range. The range. We have already defined the range as the horizontal distance cover from the point of projection to the point of landing. That's the horizontal distance known as the range. So in the syllabus, this u now is now inclined. It's like this. Is it like this? We have u here, you have theta here. It's inclined to the horizontal. We have seen it in JAMB where they will give you the distance to the vertical. If the distance to the vertical is given, definitely it will be alpha plus theta is equals to 90 degrees. Then you look for theta. Theta now will now be 90 degrees minus alpha. Always take note of that, where theta is equals to angle of projection. Angle of projection to the horizontal. Angle of projection to the horizontal. If the angle of projection to the vertical is given, definitely you have to subtract alpha, the given angle, from 90 degrees to get the angle to the horizontal. So u is an incline here, unlike in first dimension, in one dimensional projectile, where the angle is 90 degrees, it's thrown vertically upward and downward. But here it makes certain angle to the horizontal. We call it inclined velocity, initial velocity. So it is resolved into 2 components. We have uy here, you have ux here. We have uy, you have ux. So the horizontal initial velocity ux is equals to, you can say this is adjacent over hypotenuse. Definitely you are going to have cos theta is equals to ux all over u. Cos theta is equals to ux over u, where ux is equals to u cos theta. So you are going to have it to be u cos theta. Again, the vertical component, the vertical initial, the vertical component of, or the vertical initial velocity, the vertical component of initial velocity, we call it uy, which is equals to u sine theta. We call it u sine theta. Uy is equals to u sine theta. So where all this formula, this one is very important. This is very important as well. Our u is equals to initial velocity or speed. Initial velocity or speed. So how do we apply all this formula first before we move on? Let's see question in WAEC and JAMB. Let's see question 1. A body is projected vertically upward at an angle theta to the horizontal. So let me say at an angle 60 degrees to the horizontal. If the initial velocity of the body is 80 meter per second, calculate the horizontal component of the initial velocity of its initial velocity. That is one. B, find the vertical component of its initial velocity as well, of its initial velocity. Horizontal, ux is equals to u cos theta. That's the formula. That is the formula. So u is given to be 80 meter per second and theta is given to be 60 degrees. So I will say ux is equals to 80 cos 60 degrees. us is equals to 80 times, you use your calculator to look for cos 60 degrees, that is 0.5. So ux is equals to 40 meter per second. B, vertical, uy is equals to u sine theta. This one will give you 80 sine 60 degrees. 80 sine 60 degrees. This one will give you 80 times root 3 divided by 2. This one will give you 40 root 3 meter per second. That is example 1. Example 2. horizontal, the horizontal and vertical components of the initial velocity of a body projected vertically upward are 3 meter per second and 4 meter per second respectively of the initial velocity. The horizontal and vertical component of the initial velocity of a body projected vertically upward at this and this respectively. Calculate the initial velocity of the body. Calculate the initial velocity of the body. Then we are using horizontal. Ux is given to be 3 meter per second. Uy is given to be 4 meter per second. And you have to find u. This is what we don't know. You must take note of that. You have resolved this into, this is u. This is the vertical, and why this is the horizontal. Then you can use Pythagoras theorem. Using Pythagoras theorem, if Pythagoras theorem is given, is u applied, we use u square is equals to us square plus uy square. That is Pythagoras theorem. U square now is equals to, what is ux? 3 square plus 4 square. So u square now is equals to 9 plus 16. U square now is equals to 25. U now is equals to square root of 25, which is 5 meter per seconds. That is 12 meter per seconds. Okay, let's give example 3. Example 3. A particle is projected vertically upward at 30 meter per second. At 30 meter per second, if the angle of projection to the vertical is 30 degrees. Calculate the horizontal components of its initial velocity. Let's say that is what you have. So what we normally do here, when something is projected, it says it is projected like this, then this is the initial velocity here. They say to the vertical, that is 30 degree. So it means this is not the angle theta, this is angle theta to the horizontal. Definitely you have to find theta now to be equals to 90 degrees minus 30 degrees, then you need 60 degrees. And u is given to be 30 meter per second. You have to find u to the horizontal, ux, and us is equals to u cos theta. So ux now will now be, what is u? 30 or 60 degrees. Ux now is equals to 30 times 0.5. So it gives you 15 meter per seconds. That's 15 meter per second. This is where we are going to stop. Then the next video, we want to see the time taken to reach the maximum height, the time taken to reach the maximum height, the total time of flight, the maximum height attained, what happened to the distance when the maximum height has not been attained. So we talk of vertical distance, we talk of horizontal distance, then we talk of the range. We talk of the range. So please comment, share, like, and subscribe. God will bless you as you do that.